Okay. Now I'm doing the recording. So if you install Eclipse successfully, and then this will be the page like this. So here you can create a new. When you create a new, you can have a choice of the project. So I'm not going to actually create one, but I can show you that you create a new project. And then it asks you to choose what wizard, what process to create. So you can just go to Java and then create a Java project. Click on the next. And then you specify the name. So in our lab, you can say the lab line, something like that. And then it will show you the location of the project. Then from here, you just click on finish. Now this project will be created. So suppose you already create in here, I have a lecture 11 created. Then you will see that in the project explorer, it lists all the projects you created in before. So in here, you can see that the Eclipse can manage multiple Java projects. So let's go into here. And in here, there's one folder called SRC. This is the source code. So this is where the source code being stored. And of course, in here, you can have a multiple folder to organize your code. But in here, I just use the defect package. Yeah, in the default place, I create all the code. What you do is to create a code in here, you just right-click on the SRC, the source code folder, and then you go to the new. In here, you create a class. So this class is a general Java class, and I assume this one is your production code. Is the production code. So when you create a class, and then you need to give class name. So class name usually start with a capital number, like the temp, something like that. Yeah. So here and then you click on finish. Then an empty class will be generated. So in this example, I am doing the sorting. And the reason I give a sort 5 is in here, I provide 5 different sorting. And then we need to write test case to test all the sorting method we provided in this sort 5 class. So from here, you can see that I have a selection sort, the insertion sort, bubble sort, it's a heap sort, and the merge sort. So here in this class, the sort 5 class, I have these 5 different sorting methods. And then to show the sorting result, I also provide a display method. So this is a display method when you're saying, okay, first you tell me what's your sorting method you use, and then you provide the sorted result. And then this one will just display the result for you. And then suppose this sort 5 is a production code. And then I have a main program. The main program is to create a new sort 5 object, and then just give an array. array, and then it's the array as input for 5 different. The 5 different sorting members. So I can show you the result if I run this program. If I run, so this according to the data I provide, you can see this is the original data. This is unsorted data. And then here shows that by using different sorting methods, and I got the same result. I got the same result. So this is the main program. So what is the testing then? Testing is try to give a different data and then to see if actually this sorting meet my expectation. And you can use a test case as a replacement of this main. So what should I do is I go to still right click on this SRC, it's the location of the source code. And then you add a new. This time you are not adding not adding a regular class. Regular class is a Java class. Here we are trying to add a JUnit class. So usually the JUnit class will show up in here as one of the choice. But for some reason, in my IDE, I don't know why, in my previous IDE, the JUnit is always show here. Somehow in this version it doesn't show. So you go to the other, so it will be in there. So other there, you have multiple choice. So in here, so in other, first you choose Java. Still you choose Java. And then you can see, if you scroll down, there's more Java class you can choose. One of them is JUnit. You scroll down to the JUnit. You open up this JUnit and then you choose a JUnit test case. So this is the step how you create a JUnit test case. And then you go to the next. And then you need to give a name. Remember our name convention? The name convention is either start with a test or end with a test. And then what's the class you try to test? In here, for example, I try to test class sort 5, and then I give a test. Yeah, this since I already have the test 2 and 3, so here I give a test 4. So you must contain the keyword test, and it must contain class you try to test. And then for the rest of them is optional. Then you can click on that, finish. Then this test cases will be generated automatically. So in here, the import part is already there. You don't have to do much things. The only thing what you need to do is in here. What do you try to test? It's inside here. What do you try to test? So the keyword here shows that this portion is always start with the keyword is add sign add test. Shows that this method is going to run. This method is going to serve as a replacement of the main program. So this is what it does. Let's go to the code I generate, the sort of 5 test. So I can show you the code. We can see that this part is generated automatically, and this will generate automatically, and this will generate automatically. And then in here, I run this test selection sort. So this method is to test selection sort. So I can create sort 5 object called sorter. The sorter, and then I give array. So this array is an input array, and then this is my expected result. My expected result. Then I run this selection sort feed with import array. Then I use assert array equals. I use this method to check if my expected array and the actual array, are they equal? So I'm using, so this is one test I do, is to test selection sort. So similarly, another test, so you can see that the test is always start with as add test. The second test in here, I'm trying to test insertion sort. Insertion sort. So similarly, first you create a sort 5 object and the import array and the expected array, and then I give the array to the insertion sort, and then I provide the length of the array, and then similarly to check if the actual and the expected are the same. So this is for insertion sort. Similar for the bubble sort and the heap sort and the merge sort. So these are the test case I have. So in here actually one test case, including all 5 testing. And then how to run these test cases? How to run this test case? So you right click on it. You right click on it, and then you run as JUnit test. You choose this. You run as JUnit test. So if everything okay, it show you a short reporting here. So these are 5 test cases being run. In this one test case, actually is grouped by 5 small test cases. So I run 5 testing. There's no error. There's no failure. So this is the result we try to see. And then let me create some defect in turn. For example, like this. I know for this 42719 is going to return, the expected is 12479. If I change this one to 10, of course, this one is wrong, So this make, even is return a right sorting, when doing this assertion is going wrong. It's going to fail. Let's see if it actually fail. So let me run again. Just save it. Go back to here, right click, run as JUnit test. You see, this one is not green anymore. This one is not green anymore because there's one failure. Of course, I created failure on purpose just to show you that if there's anything goes wrong, it won't be green. And then it's a failure trace. So it tells you that this one is actually going wrong. You can double click on it, and then it goes to that. Okay, this statement. Yeah. You double click on this, will go to the statement and which line of the code goes wrong. And then you can examine here why it's wrong. And then in the bottom, give you the detail, the trace of the failure, and give you the report why this one is failed. You can see, I'm not sure if you can read it. Just array content differ expected 10 was 9. And so this one shows you if there's a failure, it will tell you where is a failure, which statement is wrong, and what message this one delivered. So this is the hard-coded. So I hard-code array and then do testing. So you can see that it's not that convenient if everything have to be hard-coded. And so how can I create more data? So in here, I create second version, the sort test 2. So this code is upgrading of this test. The first version. So this one contain test data. So you can see this test data compared with the first one is not just one array. It has 1, 2, 3, 4, 5. There's a 5 array. And then this one contain combination of different kind of data, like all positive data, and this all elements are the same. And this one contain the negative number, and this one contain the maximal integer and the minimal integer and the 0 and the 1. I mean the positive and negative. So you can see that data you can choose a different combination of the data to see if the sorting do well in all this data. This test data is as input, and then the expected. So whenever we design a test data, we need to provide expected. What we expected. So this one is in line with the testing data here. So here we provide, of course, this data must be correct. Be correct. And then, so in here, since we have a multiple input, we can do a for loop. We can do a for loop, and then in the for loop, test the data. We cannot just make a change to test data directly. Yeah, it's better we give the test data to another array. And similarly for the expected sorted, we give to another array. Then we do the rest. Yeah, we do the rest. And here I introduced I put a display here to show the result, show the sorting result, and showing what sorting method is. So this for loop compared with the first version of the code, you can see that there's a kind of improvement. You can choose multiple data in here, and then display the result. Let's run here. You right click, you run as JUnit. Okay, still there's nothing wrong, which is good. And then in output, these are 5 lines of data using different sorting. This is using the first data. We use 5 different kind of sorting, and they all return the expected result. And the second data, 5 different methods, and it got the same result, and so on. So here is total 5 data. And the last one, including some extreme data, the boundary data, as we're talking about. At the minimum integer is a minimum integer, and this is a maximum integer. So this is by using the for loop, but we still can see that is an improvement of the code, but still hard coded. Can we put the code? I mean, can we put the test data in a file? I mean, right? Yeah, that's more convenient. If we put the test data in a file, and then we just read from the file, then we can easily to make a change to the data. We don't have to go to the code. We can just go to the test data file and change data from there. So in order to do that, we first create 2 files. These 2 files I created in the C drive. And then the Eclipse workspace, lecture 11, SRC in this folder. Yeah, so I already created these 2 files. One is the input data. This input data is actually a copy paste from the Java code. And then I have an expected result. So in order to do that, so I create first input and expected. So these two are aligned with each other. So if you make a change in here, now you need to make a change in the expected result. So we need to make this. So it's just showing that by using these two as the input data, what the source code looks like. And the code will be something like the sort test 3. And in here, in order to read the file, we need to have input some additional library for the from Java. So in here, we need to have some I/O being I mean the classes being imported. One is I/O buffer reader and the file reader, and then the I/O to handle any exceptions. So we need to have these three. In the previous one, I forgot to mention that in the previous one, since we are going to handle, not this, this one. Yeah, we need to have an array. Yeah, the utility array. Yeah, also utility array. So this one needs to be imported. And then in here, since we don't know how long is the file, we cannot use the for loop anymore. So in this case, it's better to use the while to see if I actually reach the end of the file. So this is in the Java code, when we have exception, we always use a try and catch. Try and catch is a standard for the Java. So if anything goes wrong in here, it's going to catch the exceptions. So in here, we first read from the file. So we read from the file, and then we run this while loop. We run this while loop to make sure first we check if we actually read. We go to the end of the line. If we go to the end of the line, of course, this one will be long, right? Yeah. So we want to make sure both file are not. We have not reached the end of the both file. So both file, they're not long. Then we just read line by line. Yeah, just read line. Just read line by line, and then for the JUnit assertion is the same. So this one is the same, but the only difference is this one compared with previous one. Previous one is hard-coded data, and the third one we store the data in a file. This one gives us more flexibility to make change to data without changing the code. So similarly, we can just right-click on it and run as JUnit. Run as JUnit. So you can see the console output is the same as the previous one. So from the result, we won't tell the difference. The only difference is the data is in different location. And this one shows that is green, which means it's right. Okay. So in here we can see that we have how many test cases? 1, 2, 3, 4. We have 1, 2, 3. We have 3 test cases. Can we run these 3 test cases as a group? So this shows that while we have the production code, so our job is working on the production code, blah, blah, do whatever change. Anytime when we finish doing the changing, then I need to go back to run all the test cases. I want to, if I make a change to the production code, I need to run all the test cases. How can I do that? So here is you still right-click on here. Then you can just run the whole package. You can just run as. You can just So just choose a Java test, or in the JUnit test, and then you will run all the tests in there. See, this one will run all the tests, all the tests in this folder. So this one is very convenient. You're just focusing on the production code. Once finished, then you just run all the unit testing, all the test cases in this folder. If it's passed, then you can check in the code. So this is the process. So our lab line will follow the same strategy. We'll follow the same process I demo in here. I can show you the lab. Lab document. So by the way, the source code and the JUnit code I already post on the canvas. And also this lecture has been recorded. So you will have everything you need to working on your lab. Your lab is not as complicated as I show you, as I show you the sample code. Your lab line source code is much simple, but the process is the same. So the lab line, you first create a new Java project. So I will show you how to do that in the Eclipse. And then the second step, add a new Java class. So we also show you that how to do that. To add a new Java class, right click on it, choose a new, choose a class, and then give a name. And the name in the lab, name should be the largest. Should be the largest. That's the class name. And then you copy the production code I provide. So this is production code. So this is source code under test. Of course, this code has some defect. Yeah, has some defect. And I need you to run the test cases. And if you choose the right test data, this test should fail. Then you know that if the data is right and the result is wrong, then I know the code has something wrong. So you can copy and paste my code to here, right? Yeah, I mean to the class you just generated. You just copy and paste in here. Step C is add a JUnit test in the project. So to add a JUnit test, you still go in here. You choose a new, and then you choose other. You choose a Java project, so I can show you where the location it is. So you go, in here, you choose Java, JUnit test case. You choose this one, and then give a name. So the name should be test, keyword test with the largest. So this will be the name of the JUnit test case. And then you develop code to to run the test. So this part I rely on yourself to do. So this code you can refer to what I have here. Here with a test, and then test method provided the hard data, the hard coded data, and then use assert. But in here, asserting you use is not assert array equal, because this one assert equal is to compare to array, right? But in here, is the largest number. Largest number is just two number. So in order to check two number, you just use a third equal. You can just use a third equal. You don't have to use a third array equal. Use a third equal. But the code the source code is very similar to what I have here. You just use a third circle instead of a third array equals. So the D is you have your initial code ready and with hard-coded data. And step E is to compile the data into separate files. So you have test data, expected result, similar to what I provide. Similar to what I provide in here, input data and expected data. So in here, similarly here. So you have the array as the input, and of course the expected result will be just one number, right? So just larger number of each of this array, but you put it into two files. And then modify the code. So while loop, read from the file, and then read the data from the file and do the comparison. So similarly to the code I provide. Test 3. Test 3 is illustrate how to get the data from the file and read line by line and do the comparison. So you can just follow the similar code I provide. Only difference is my code is compared to array, and your code is to compare to integer. So this I believe you can figure out yourself how to do that. Yeah, since the production code I provide has some defect, then the test cases you provide the hard coded or with the file is going to fail. So this indicates the largest. This production code has some defect, and then you fix defect and then rerun the test. So in your submission, you submit one MS Word document showing the output of the unit testing, including both failed and passed. And then the final output, and all test case pass, and the source code of the source code of the test cases, and the source code of the final production code. And please provide the data as well. You copy and paste the data in the Word document, the test data and the expected result. So this just provide one Word document. That's it. So this is a lab line, very similar to what I show you in here. So in Canvas, I already post the code of this sort 5. You can just look at it on your own pace after the class. We go to lecture note. I post today's lecture. 11, today's lecture. I'm sorry, yeah. Today's lecture and the week 12 sorted file. These contain the source code. Contain source code I gave. And also today's lecture PDF. Okay, any question regarding the lab? So I know if you are not familiar with Java, or if this is the first time you're working with Java, it may sound like overwhelming, but but I still believe you can handle it. The code itself has nothing surprise. Even you are new to the Java, the code is very self-explained, and all the algorithm in here. If you take the data structure course, yeah, I believe you already know the sorting. Yeah, this is very basic the sorting algorithm, and you must learn that in your data structure course. Okay. Today I also post the final exam instruction. Okay. The final exam will be on Tuesday, December 14, 3 to 5. So this time I give you 2 hours, because in the midterm exam, some of you saying that there's not enough time. So here you got a 15 minutes more. Location still in the lab. Open book and open note. And here is some important note. So first, don't be late, and all your answer will be in a Word document. If you prefer, like a drawing diagram by hand, if that's the case you prefer, you can also write on a piece of paper and then take a picture. You can do that as well. You can do that too. Here I want to highlight you are not allowed to use any tool to communicate with other students, because the TA report to me that some of you use the Discord to communicate with other students. So that's considered a cheat. So in the final exam, you are not allowed to use in the tool. You have to work on the final exam all by yourself. You cannot just send an email using Discord or use whatever software. There's so many software you can use to communicate with others, but you cannot do that in the final exam. And the TA will watch you closely, and they will consider the fail if you do that. And the tools involve Enterprise Architect for the UML, and the VS Code, so it's just one Java IDE. So as your choice, you can choose Eclipse, NetBeans, or VS Code. So the final exam is about JUnit. All three IDE has JUnit add-on. So in here, the Eclipse and the NetBeans, as long as you install it still, you don't have to install the JUnit separately. The VS Code, JUnit is not coming with it. If you use a VS Code, you need to install the JUnit separately. And Git and GitHub, so this, I assume you already have them. So the topic, some likely problem is I want to show you I give you a description of simple system and ask you to draw the use case diagram, class diagram, sequence diagram, state activity diagram. So this all come from a simple system. And of course, this simple system is not as sophisticated as your term project. It's a very simple one. So, however, you're going to practice in higher process. Get a use case. From the use case, you have a class diagram. From class diagram, you have a sequence diagram. From class diagram, you can draw state diagram and so on. So this is how this problem will be. And then for the testing is what we discussed today. You know how to use assertion in the unit testing, and you know how to write a unit test case. And then when you design data, you are not just randomly using the data. The data needed to follow this boundary. So which means it has some extreme data. You cannot just always have the 1, 2, 3, 4, 5 very simple data. The data itself contains some extreme. Yeah, the maximum, minimum, or like something in between. This is always some boundary data. And here use Git and GitHub to manage source code and test cases. So actually, this is a part of your lab 10. Lab 10, you're going to practice this. Up to now, you already we already cover all the topic. Jenkins, no, Jenkins is not. Because JUnit is about unit testing. The Jenkins is for integration testing. There's different purpose. We are now practicing. Partition. Yeah, equivalent partition is yeah. For example, like data we have here, integer data, right? So integer data, if they have, I mean, the equivalent partition is, I mean, the data has both negative and positive. They have data on both sides. We call the equivalent. Yeah, so that's we call the equivalent partition. Data is not on one side. It's not always positive, not always negative. Contain data balance in two different.
So that's what we're gonna test.
Yeah, that's, I mean, that refers to test the data itself. So when we compile the test data, we follow the rule equivalent partitioning. It means data has a different kind. So in here, in this case, we have negative, positive. So the boundary data, boundary means we have extreme data, the maximum, minimum. So this one is an example. So what if the data is not integer? What if the data is what if data is a string? Is there any like maximum data for the string? So if data is string, there's so there's also the limitation. For example, a string is usually 255 in length. So you can create a string that long, or create a string is empty string. So empty string and the maximum length of the string also considered as extreme data, as boundary data. So for all kind of data, for doesn't matter for what kind of data type, there's always some limitation. So when you go to the limitation, the boundary, we call the boundary analysis. Okay. So that's the final exam. Any question regarding the final? The lab? Okay, so yeah.
So regarding the project,
Uh-huh.
are we working on what we're doing in lab right now, the same exact file we're doing in lab, or are we creating a whole new different file?
No, you don't have to. I mean, you progressively adding more things in your lab. Yeah, don't create a new one. I mean, which means you have to start over again. Yeah, that's too much. Yeah.
For the final, when it says draw use case or path diagram, all those, it means that you do it at Enterprise Architect and then for the screen that basically.
Yeah, if you are very familiar with Enterprise Architect, and if you practice well, you can use Enterprise Architect, but that's not mandatory. Sometimes you say, I join the class diagram by hand is faster than using a tool. If that's the case, you can draw by hand and then take a picture. Yes. Yeah, you can. Yeah, you can use that tool. Yeah, that's okay. I don't care what tool you use. So here, I just suggest you use Enterprise Architect or by hand. If you prefer some other tool, you think you believe you draw faster, then you are welcome to do so. Okay. But use case, remember the use case is not oval shape. Yeah, the use case, you need to provide the flow of event. So, so even you use any tool to draw the use case, you copy and paste the shape into the Word document. Please also copy and paste the flow of event. I want to see that. Okay. Okay, if there's no question, then I think that's it for today.